esse pequeno atraso, mais uma promessa de que amanhã vai dar tudo certo. Vamos ser pontuais, 9 da manhã, tá começando, tá? Então, agora, vamos dar início, então, a esse evento, o 10º DIG-GEGAL, nessa junção de duas conferências, das mais importantes na área de geoarqueologia, no planeta, né? Um com um foco mais hemisfério norte e outro mais com um foco América Latina, né? Que é o nosso grupo, muito ativo. E a ideia desse evento foi bem fazer a junção dos dois, para que seja um evento totalmente internacional, que as pessoas se conheçam, que interajam de verdade, e a gente poder entrar em contato, ter ideias, pensar em colaborações, etc., né? Algo que realmente seja um evento interdisciplinar e internacional, que esse era o nosso objetivo. Então, para essa mesa de abertura, eu chamei a representação de cada um dos congressos e também do Museu de Arqueologia e Etnologia, que é a nossa instituição, a UMAE, da Universidade de São Paulo, que está nos apoiando também na organização desse evento. Para isso, eu chamei o professor Camilo Vasconcelos, que é o nosso vice-diretor atualmente no UMAE. Também chamamos, então, a Lucy Wilson, que é representante aqui do DIG, do Development International Geoarchaeology, ela que foi a criadora do evento, né? A impulsora desses congressos que se fazem a cada 2 anos, e a Rosicler Teodoro da Silva, da PUC de Goiás, aqui de Brasil, ela é a representante do GEGAL no Brasil, e ela veio também a representação do Christian Fabier Duan, que estaria aqui na mesa com a gente como coordenador geral do GEGAL, mas que infelizmente ele teve que cancelar a viagem por questões de saúde, inclusive o curso que ia acontecer depois, que acredito que se vocês se inscreveram, tivemos que cancelar também, ele estava super triste com o que aconteceu, mas assim, uma questão de saúde, eventualmente ele voltará ao Brasil mais para frente. Então, a Rosicler vai fazer a representação dupla do GEGAL aqui nessa cerimônia de abertura. Então, eu gostaria de passar a palavra primeiro para o professor Camilo, depois a Lucy e a Rosicler, e eu só falo umas palavras finais, antes da palestra inaugural, que será da professora Carolina Mallol.
Bem, boa tarde a todos e todas. É um prazer enorme estar aqui na cerimônia de abertura do Congresso Internacional de Geoarqueologia e do Grupo de Estudos de Geoarqueologia também da América Latina. Eu falo em nome do professor Eduardo Neves também, que é o nosso diretor, que está em viagem ao exterior, e eu, na condição de vice-diretor, agradeço muitíssimo a presença de vocês, dos inscritos, a professora Rimena, que trabalha com a gente lá no MAI, parabenizo pela iniciativa, pelo esforço. Sei que não é fácil organizar um encontro nos dias atuais, e quero também agradecer às pessoas que fazem parte da mesa e dar as boas-vindas a vocês, esperando que o congresso esteja pleno de reflexões e colaborações e interações entre os diversos países que integram o GEGAL e as pessoas que vieram para o Congresso Internacional também, e dizer que nós lá do Museu de Arqueologia e Etnologia estamos à disposição para o que precisem, para o que necessitarem, e desejo que o Congresso seja o mais fértil e promissor possível em termos das experiências que eu tenho certeza que serão muito proveitosas. Então, agradeço muito e também felicito a comissão organizadora e a comissão científica pela organização do evento. Obrigado.
Okay, I have to speak English because that's what I speak. Or French, but that would be much easier. I am, in fact, one of the creators, I guess, of DIG. We hosted the first DIG in 2005 in St. John, New Brunswick in Canada, which is where I'm from. And it was a success, and it has carried on every second year since then. We have actually had a long history of people from the Southern Hemisphere coming to DIG, from various countries in Latin America, from Southern Africa, and so on. So it's really nice to actually be here and not make you travel. We travel to you. This is our 7th country and 3rd continent and 2nd hemisphere for DIG. DIG itself is a a small steering committee of people. It's not a formal organization. There's no membership. There are no fees. It's just a group of people who try to make sure that a conference happens every second year. That's it. That's what we do. And it only happens because of the hard work and the willingness of people like Gina and other people who have breaking down this year. This was a nice one before. And it only happens because people want it. We couldn't make a conference without people wanting to have a conference. So because of all of you, and because of their hard work, I'm sure we'll have an excellent conference. Right now we can say thank you for doing all this work to get us this far. And I'm very confident that in a few days we'll be saying thank you for having made such an excellent conference. Hopefully. So, thank you.
Eu vou tentar ser o mais breve possível, mas esse foi um evento bastante interessante para todos nós. Um breve resumo. Em 2012, durante o 6º Encontro de Teoria Arqueológica da América do Sul, 6º TAS, realizado na cidade de Goiânia, Goiás, Júlio, Cristian, eu, professor Carlos Lopes, professora Marta Cecília Cano, Marisa Coutinho e Michele Tizuma, ao redor de uma mesa durante o almoço no Hotel Augustus, em Goiânia, resolvemos criar, vamos assim dizer, organizar um grupo de estudos em geoarqueologia na América Latina, né, com o objetivo de integrar, trocar experiências e desenvolver atividades nessa área. Nossa primeira reunião foi em Olavarria, no ano seguinte, e de lá até o momento nos reunimos anualmente em diversas cidades da América Latina: Olavarria, Argentina, Los Vilos, Argentina, Chile, Quito, Equador, La Paloma, Uruguai, Manizales, Colômbia, Ubajara, Brasil, Lima, Peru, México, Cidade do México e agora em São Paulo, onde discutimos, trocamos ideias e compartilhamos algumas das problemáticas das pesquisas em desenvolvimento. Destaco também o fato de termos realizado atividades de campo em todos os encontros, exceção, é claro, do ano de 2021, em plena pandemia, onde nós realizamos um evento totalmente virtual. Né? Ao longo desses 10 anos do Encontro DIG-GEGAL, foi possível agregar mais de 250 membros de 14 países da América Latina e realizar até o momento 7 cursos com a participação de mais de 200 alunos e publicação de livros e vários artigos em periódicos nacionais e internacionais. Este ano, estamos realizando o nosso encontro presencial em conjunto com o 10º TIG, o que para nós é muito gratificante e enriquecedor, principalmente após um período tão doloroso, onde todos nós tivemos perdas de colegas, amigos, familiares e principalmente alguns alunos. Neste período, pós-pandemia, sofremos também com os cortes de verbas para as pesquisas em todos os países. Contudo, não deixamos de realizá-los, mesmo que de maneira mais lenta, continuamos produzindo conhecimento, que esse é o nosso objetivo maior. Esse evento é um marco para a arqueologia e para a geoarqueologia e para a comunidade científica geral, por ser o primeiro a ser realizado de maneira presencial após a pandemia. Isso é extremamente importante. E, em uma tarde, em um restaurante, surgiu uma ideia, e dessa ideia, um grupo de estudo, hoje uma referência. Então, gostaria de desejar a todos muito bem-vindos, todas e todos, né? Bem-vindos, né, ao nosso encontro do 10º DIG-GEGAL e DIG. Tá? Muito obrigada.
Então, só para terminar a mesa de abertura, eu queria agradecer pessoalmente a comissão organizadora do evento, que além de mim tem a Rosicler, tem o Júlio, o Rubim e tem também o pessoal que estava aqui em São Paulo dando uma super ajuda com toda a organização, aquele Brandão, Maiara Mariano, Nicolás Natasha, Michele Tizuka, que nos ajudou à distância e não conseguiu vir, mas que também foi super ativa na divulgação nas redes. Mas eu queria realmente agradecer Kelly, Maiara e Nicolás, pessoalmente, pelo trabalho árduo também em montar todo esse evento, toda essa infraestrutura. Obviamente, não fiz tudo sozinha, então acho que eles merecem todo esse crédito. Sem essa equipe, isso aqui não ia... Mesmo que se peguei no imprevisto, ia ser 50 vezes pior. Não, realmente a gente precisa desse apoio dos estudantes e eles super ajudaram. E queria agradecer também a comissão científica que avaliou todos os trabalhos, também a Rosicler está envolvida, o Cristian Fabio Dubois, a Carola Cacinheira da Argentina e a Laura de Puerto também do Uruguai, eu, Nicolás, também que atuamos na avaliação dos trabalhos. Tá? Então, eu queria deixar também registrado esse agradecimento à comissão científica e esperamos, então, ter uma boa semana de conferência, que todo mundo aproveite para conversar, para trocar ideias, para se sentir orgulhosos de trazer esse grande evento aqui ao Brasil, América do Sul, pela primeira vez, juntando duas grandes conferências e que a gente consiga sair daqui feliz, com muito conhecimento, com contatos e muito felizes de ter vindo para o Brasil, para quem não veio pela primeira vez, conhecer esses trópicos. E desejo para todos, então, uma ótima semana nesse congresso. E gostaria, então, de passar a palavra para a Carolina, para fazer esse inaugural dela. Carolina, por favor. Muito obrigada, gente. Só te apresento
aumentar o ar-condicionado. Grava frio. Já pedi, já. Ah, tá. Isso é que já tentamos mexer aqui, já também não foi.
Eu convidei ela a mesmo, assim, especialmente para ser a nossa palestrante inaugural, porque eu sou fã do trabalho da Carolina desde que eu comecei a trabalhar com geoarqueologia. Que uma vez eu estava, como tudo, você vai preparar a nossa bibliografia para dissertação, para tese, etc. Aí me aparece um trabalho que chama What's on a Beach? O que tem numa praia? Eu disse, opa, isso aqui é interessante, o que será que tinha? E já o título, né, cativou, e a partir de lá eu virei uma voraz leitora de todas as publicações da Carolina, que tem se renovado ao longo do tempo, né, inovando muito na geoarqueologia, começando desde a micromorfologia, mas agora incorporando técnicas complementares, liderando seu próprio laboratório. A Carolina, ela é professora na Universidade de La Laguna, em Tenerife, estudou na Espanha, fez a sua graduação na Espanha, doutorado na Universidade de Harvard, trabalhando com contextos do Paleolítico Inferior Europeu, e ela teve vários financiamentos internacionais para pesquisa, também financiados pelo governo espanhol, e lidera um laboratório super importante, onde o foco é essa aplicação dessas técnicas de alta resolução ao estudo do registro arqueológico através da micromorfologia, trazendo resultados impressionantes, né, para a gente entender no mínimo detalhe a formação dos contextos arqueológicos. Então, para mim, era muito importante ter ela aqui como mulher pesquisadora, geoarqueóloga, espanhola com família colombiana, né? Então, tinha tudo a ver com essa proposta desse evento sul-americano, com coração na América do Sul, né? Apesar de ter um espírito internacional. Eu queria agradecer muito a Carolina também por ter aceitado o convite e ser a nossa palestrante inaugural hoje. Obrigada, Carolina. Chegou a tradutora. Na hora que eu terminei de falar, parece que isso aqui está cronometrado. Então, espera um pouquinho até que já se aceite. Quem está com os fones, então, já pode pôr. E daqui a pouco ela vai, de alguma maneira, traduzir em cima da hora, mas vai fazer o melhor. ¿Cómo? No me digas, qué crecimiento. Yo vengo ucraniano. Me quedo aquí. ¿Quieres estar? Para salir, tal vez aquí. ¿Así? Sí. Porque aí hay una forma de colocar. Maria, onde que ela pode ficar melhor? Desse lado ou daquele? Aqui melhor? Ah, então sim. porque no nos sabe. Y estamos viendo si hay una botella. Ahora cuando me ve lo que es, no, pero todo el mundo, bueno, yo dije, está presente, se van a traer una cuota.
Okay. All right. First and foremost, thank you, Ximena. It's really an honor for me to be here. And I apologize. I would like to, at least in the beginning, say thank you to the attendees in Portuguese, in Brazilian, and speak your language and communicate more directly to you. For me, it's very relevant that a DIG meeting is organized in South America. I think that I am a little bit, as much as I can, involved in the developing of geoarchaeology of this continent. It's in a special place in my heart, in my personal life as well, and I have participated as much as I have been able to in these meetings and also in work in this continent. So I congratulate you, Ximena, for organizing this and for all of you to be here. And as she said, to get contacts, to talk to each other, to get ideas and to advance together. This is what this meeting is about. I am going to speak to you in a bit of an eclectic way. I'm going to communicate what I have been working on lately in the last years, you know, what I have been developing in my own lab, in my own behalf. And I'm going to share some, I'm going to share some of my latest results, my latest advances, my latest approaches. And I hope that in the following days, we can discuss about them and we can talk about possibilities of collaborations together. So I'll just begin. Geoarchaeology today, I think we are in a good place. I think that this is looking good. I think that we're lucky because we are working in a time in which there's a lot of maturity in the archaeological discipline. You know, we've come a long way, a few centuries, and it's very scientific at the moment. So it's interdisciplinary, scientific, and not only that, it's integrative. So in most of the teams that I've been able to work with, there's an integration of a more traditional archaeology and the archaeological sciences, which is very good. We can isolate ourselves when we do archaeological science or vice versa. So right now, I think we are in a good place because there's talking to each other. We are globalized, which is also very good. You know, it's easy to communicate worldwide and our science is shared and updated in a global scale. So more minds advance more. So all of these things are very good. And the other good thing is that a lot of attention is being paid to the sediment. So context and sediment and stratigraphy is more and more important. So there is more and more demand for geoarchaeology generally, and then specifically also for certain techniques. And it has been clear that the geoarchaeological perspective contributes a lot to any kind of archaeology. So this is our starting point. So I think among the archaeological disciplines, we are in a very good time right now, I would say. We are also in a very good time that is going really, really fast, and it's advancing really, really quickly, which is, it's stemming a little bit from what already Christian Christiansen, a Danish archaeologist that works in Sweden, already kind of talked a lot about this, the third revolution in archaeology, the bioarchaeological revolution. This is now a fact, it's happening, that it's going really fast. So there is more and more interest in bioarchaeology. And I think that more and more specialists are taking an approach that incorporates bioarchaeology because it has contributed a lot of important information. It makes sense to me because the human world is very organic, and our world, it is organic. Our cells are organic, and there was, and archaeology was born from geology. It's a more inorganic discipline, based on stratigraphy and based on material things that are more part of the mineral world, so that we are very familiar with as geoarchaeologists. But now we're opening this Pandora box of bio things that is going very quickly. And I personally like the way in which it's happening. I think that it's happening in a promising way because there is there is increasing training of archaeological scientists that are working in bioarchaeology. If you remember, if you read the history of geoarchaeology, for a long time, for a lot of decades, it was geologists that were working for archaeologists and providing geological information, and not archaeologists. And it took a long time before archaeologists were trained in geoarchaeology. But bioarchaeology has come in a time where the instruments are more accessible, scientific instruments. It's cheaper, archaeology institutes can have access to some of those instruments. And archaeologists can get training in some of these special techniques. And so already we see that many of the bioarchaeologists are archaeologists by training. So it's kind of starting in a faster track than geoarchaeology did. But it's working together. So we have in the latest years, since Svante Pavel started to do all the genetic work, and there's more and more research that is happening from the sediments. So we can obtain DNA from the sediments. We can obtain DNA from sediments that are intact in place. And my colleagues will talk about this much more in depth this week later. But this is a revolution. It's a true revolution. So we are kind of in the first train of this revolution. We're up front there. And I think that's why I mean that it's very exciting times. What I'm going to talk to you about today is what we do from our lab is based in the Canary Islands, and we are a team of archaeologists, geologists, and chemists. We come from different backgrounds, but we are working all for solving archaeological problems. And we have a strong focus on bioarchaeology from geoarchaeology. So I'm going to give you a few examples of the work we have been doing, and I'm going to center on Paleolithic examples. We are carrying out work in a site in eastern Spain, in Alcoy, called El Salt, and another site called Abric del Pastor. They are Neanderthal sites. And it's not our exclusive focus, but they have motivated many of the approaches and techniques that we use now that I'm going to talk about. So I'm going to be focusing on the contributions of this work from these sites and the work we do in Tenerife. I want to here point out that our work right now, we consider it a little bit pioneering. We are pioneering a field of application in geoarchaeology. So we have a lot of emphasis on experimental work and reference building. So reference collection building and improvement of protocols. So in that way, our chemists are helping a lot because they have the right background and training to tune scientific protocols to be adjusted to archaeological problems and archaeological context. And in some cases, some of the studies we do of archaeological context are also reference material for us. They help us to develop this field. I think you will see what I mean later on when I tell you some examples. But well, the main thing, and just to speak a little bit about my motivation to jump into this bioarchaeological revolution, was from my experience as a micromorphologist. I'm a micromorphologist. I study sediments in thin section I study microstratigraphies to look for clues about the past. And I have seen a lot of organic remains in there. They are there. They're always there. But as geoarchaeologists, we tend to speak more of the story of what happened after the people were gone. You know, there's a lot of time between the abandonment of the site and today, with a lot of processes that we have to deconstruct. You know, diagenesis, alteration, weathering, time, bioturbation, all these processes, site formation processes is our battle horse of geoarchaeologists. And often we forget about that story of what did the humans do there, we really care about that. And it's frustrating to see that we have so much organic matter in those thin sections that is not the protagonist of the story necessarily. So that was a little bit the motivation behind it. And most of the organic matter is burned because burning preserves organic matter when it's at low temperatures. So bacterial degradation and other degradation by other agents, including mesofauna and everything that happens in the soil, is not so strong when the remains are burned because they're not so nutritious, right? So they're left behind and they have a good preservation potential. But they still keep a lot of information that for us is good because it can help us, it can provide clues about what it was. So charred organic matter is an interesting target for analysis. And we have focused on trying to figure out what that charred stuff was on thin sections. That's how it all began. That was the initial motivation. And what we're doing now is developing the application of analyzing lipid residues, lipids, so fats and waxes and oils, which are hydrophobic, so they have a high preservation potential. They're not so susceptible to diagenesis and weathering. And we want to target the analysis of these compounds, which are usually at a molecular level, target the ones that are in burn context, because we know that there's a higher potential for their preservation. So what we do is apply a field called the lipid biomarker analysis, which is originally more commonly applied to the field of paleoclimate investigations, generally to reconstruct climate based on the molecular remains of leaf waxes and all the vegetation that leaves behind molecular traces. So we apply those same techniques, including isotopic analysis of these molecular plant residues or animal residues. We do isotope analysis, and you all know that isotopes are very informative. Isotopes is the other part of this bioarchaeological revolution. There's genetics and there's isotopic archaeology. It's becoming very, very prominent in archaeology. So we are all familiar in the 21st century archaeology that we analyze carbon isotopes, hydrogen isotopes, oxygen isotopes. What we do is analyze the isotopes of the molecular remains of lipids that are preserved in the sediment for the same purposes, for reconstructing climate and reconstructing diet. So that is the main approach that we do in our lab. And we are also applying magnetism because we were originally interested in fire, right? Our target is these charred sediments that have a lot of information. Another way to get more information of them is by investigating the magnetic properties, because burning at a certain threshold of temperature, it has to be high enough, but burning can help you not only know a little bit more about the conditions of, like the temperatures of firing, but also it's a way to obtain relative days or even absolute days, depending on what chronology you are working with. So that is something that is very interesting, that is a field that exists already independently, but in our lab, we want to do micro-contextual research. Micro-contextual research is considering the microstratigraphy as like a Google Maps. You know, it's like, it helps us to see where we are and gives us a context, a micro-context. And everything that we can do to that micro-context, every technique we can apply, combining the thin sections and these special techniques, will be very powerful because we have temporal and a spatial control. Temporal and spatial control in archaeology of the 21st century is basic. It's the relationship between all the archaeological elements. So when we do it at a microscopic scale, we are very near to behavior because we are working at smaller temporal scales of generations, scales at which culture changes and climate changes. So that's why microstratigraphy has to be the anchor of all these studies. And as I said, these studies, lipid analysis, archaeomagnetism, they exist already. What we are trying to challenge is the combination between the microcontext and these high-resolution information. I'm going to start with the case studies. There's other techniques that we're trying to apply, but I will only focus on these two right now with these case studies. And I'm going to jump to the Paleolithic a little bit. The Paleolithic, I have worked years and years in the Paleolithic, and it's very inspiring. It's very challenging because there's not much information. So it's been a source of archaeological advance in methods because of the need. You know, we have nothing. So we have to find ways of getting to those people when there is nothing. There's a few bones and a few stones and a lot of soil or sediment. And you have to know how the Paleolithic was. This is very difficult. It's very challenging. So that's why from the Paleolithic, there has been always a lot of method development that later has been incorporated into the study of other periods, more recent prehistory or history. So the Paleolithic continues to be very scanty in data and in information, and continues to be an engine of method development. So that's why I would like to also talk about the Paleolithic today. And the work we are doing is in two sites in eastern Spain that are close together. They're only 5 kilometers apart. And this is another thing that I consider that it's important when we want to look at change and behavior and people. It's good to have more than one site because you have a better picture of the territory of those people and of different groups if you manage to have sites that are from the same time period. So it's very difficult. It's very difficult to have already one site. So having two is difficult, but if you have two and you have them within the same region, it's good. And we are making an effort to do that. That's why we are carrying out work in these two sites. We are trying to help solve a problem around the disappearance of Neanderthals. The Neanderthals as a population disappeared around 40,000 years ago. That's like the latest evidence that we have from them. And we have very good climatic records of what happened around that time. Actually, what happened in the Pleistocene, we have a good control of that. You can see all these wiggles is where we know that it was warmer or colder. And there's a lot of sites that tells that around between 50 and 40,000, the Neanderthal population was not stable, and then it disappeared. And that's what we know. That's what we have to work with. That's what it's enigmatic. It's a problem that is very interesting. The Iberian Peninsula specifically is interesting because it has been traditionally considered as a refugium because it's warmer. So it has a warmer latitude, also in the Paleolithic, and it has conditions that, from what we know, the Iberian Peninsula during the cold periods was getting drier, not so much colder like in Central Europe or Northern Europe, but it was more, the humidity was changed, so it got drier. So it got warmer and drier. And hypothetically, it appears that in the warm periods of the Pleistocene, the Iberian Peninsula was comparable to today. And in the cold periods where you had steppes and mammoths in Central Europe, you also had a few mammoths that came down, of course, they went, but it wasn't so harsh. And they were still a good habitat for humans. And there's a lot of Neanderthals there still. So it's considered a good context to study the disappearance of Neanderthals because maybe it was a bottleneck where they just came there to disappear. So that is the interest of this period in Spain. But then it gets complicated because there's all these theories already. We don't have any data, right? We have very few information, but there's a lot of theories about what happened. So we have to play around with them and we have to consider them because they are out there in the literature. And they're possible, of course, so you want to test them. But some of them are related with modern humans, the arrival of modern humans, how that happens. Other ones not. Other ones are related to climate change or volcanoes or things that have nothing to do with modern humans. And there's researchers that like one set of theories better and others prefer the other. But they're all very complicated. They're very difficult to solve. We all want to solve them, but the problem is that the temporal scale at which we are working, I think it's not adequate because we are talking about something that probably happened in generations. Maybe it happened in millennia, but really it happened in generations if we're talking about modern humans and Neanderthal interactions. And the temporal resolution of the dates in the Paleolithic is not high enough. And the resolution of the archaeology is not high enough. We excavate layers that have a lot of time inside, a lot of discontinuities, a lot of complexity, and we are excavating the material inside those layers and trying to do technology on them and putting it together to test these hypotheses. That is very difficult because if there's a possibility that maybe the change that led to the Neanderthal disappearance was very subtle or very gradual, for example, conditions that changed that made Neanderthals stop going to a certain territory and start going to another one. And then you stop exploiting that flint and you start exploiting another one. We don't have the temporal resolution to see that. We have all the flint together in one bag. And then the experts study it together. So it's a bit of a handicap. It's something that is known as a palimpsest effect. It's everything is together. And who can help? Well, microstratigraphy can help, right? That is what we do. We try to narrow down the temporal resolution for one. That's one of the things we can do. So this is not the puzzle we have. This is the puzzle you need to reconstruct, to test those hypotheses that I wrote there. But we don't have that. This is what we have. This is really what we have. When you analyze archaeological data from the Paleolithic, and you see these papers, the papers tell you about diet or with very high resolution is really in one piece. And it's one piece that you don't know where it goes in the puzzle. So it's very difficult. And archaeological scientists, I think, that are working the Paleolithic, that sometimes we are defined as very technical and not very theoretical. I really think this is it's a misconception, because we are consciously deciding that these data points are essential to test the hypothesis. So we put the hypothesis aside and we dedicate to contributing small grains of sand. That is what we do. So what about if we call ourselves microhistorians or something like that? You know, I'm trying to redeem an approach in which you are contributing small pieces of information, you know, bits, snapshots of the past, which is what we contribute with our high resolution techniques. And that snapshot is a moment of humans adapted to a specific kind of environment. It's talking about climate, it's talking about adaptation, human groups, diet, many, many things. And that piece of the puzzle is going to be very relevant to get to know those people better. And then you will get to know why they changed, if they changed. But this is an approach that is not new. There's a mistake here. So it's not 1863, it's 1959. This is microhistory is a field. Okay, it's a field that appeared in historians out of the frustration of big discourse and big narratives, and it was a fight for the everyday life. So what people do, what I do every day, from the moment I wake up till I go to bed, what time I brush my teeth, what time I have lunch, my habits, that is something that defines cultures and society. And when that changes, that is culture change. So from the small scale of reconstructing people's lives, which is what microhistory is, you can later on approach change and approach other issues that are historically relevant. So this is an approach, as I said, that is applied since maybe 1959, 1970, and it's already there. It hasn't been applied much to archaeology or history at all. But I think, if you think about it, it's a little bit what we do. We're not just reconstructing an isotope that tells you that it was raining a lot. We are, because of that first slide where I said people talk to each other nowadays, that isotope, I put it together with the information from the lithic analyst that tells me that I have this tool and it was used to butcher meat. So we have a lot of this anecdotic data that put together reconstructs a picture, a snapshot of time. So I think, just to trying to conceptualize my thinking, trying to understand my theoretical approach, I think that is what we do. That is what we are doing. So back to El Salt. El Salt is a very big site in eastern Spain. It's behind this wall. There's a very, very tall 40-meter wall there. And that wall serves as a bit of a shelter for people. So it's a wall site, not a cave or open air, it's a wall site. And the preservation is excellent. It's very good because it's all springs and limestone is very alkaline. So preservation is very good there. And we are lucky enough to have this sequence that is about 4 meters tall. And there's a lot of room to do microstratigraphy because there's already dates. We have some dates, and it dates to the right time to study Neanderthal disappearance. It dates more or less from 80,000 years ago to 40,000 years ago. So it's exactly that time that we're interested on. And we also have some human remains. We have some teeth of Neanderthals towards the top. And we also have, after the deposit of the teeth, we have a segment that is sterile with no archaeology. For some time, we don't know how much, And then we have some lithic industry that is not typical of Neanderthals. It's some other population. So it's a very interesting setting to study. And this is what we started to investigate. So one key thing is that the fires are very well preserved. And remember, fires for us are important. They're full of organics. And another thing about fires is that they mark the surface of human life. Because Neanderthals didn't have ovens or anything like that. They just made barbecues on the floor. So if you burn the floor, you're preserving your floor. So if you have trash there and you make a fire, suddenly the archaeologist of the future is going to have a little round circle of all the trash and a little clues about your life because you burned that floor. So that's very good. And we have a lot of fires. We have found and excavated more than 180 fires. So it's really a lot. So that's, of course, we have to study that, right? So the excavation right now in El Sal is really a geoarchaeological excavation. I mean, it's very slow. We excavate 1 month per year, and it's just samples. Samples for this and samples for that, you know, millimeter samples, aluminum foil, plastic is 3D, all sediment samples. And that's the focus. We give a lot of importance for that, and then we analyze the microscopic world, you know, charcoal and pollen and phytoliths and minerals and diagenesis. And then we also do organic studies. We have collaborators that do the DNA, sedimentary DNA, isotopic work, and then our lithic work. Here you see just a snapshot of the excavation where we excavate with nitrile gloves so that we don't contaminate the lipid signature. We collect micromorphology and archaeomagnetism blocks of the fires side and side, always. So it's a very slow excavation, and it's very, the objective has become dissecting these palimpsests, just narrowing down the time scale, also for the lithic analysts and for the bone specialists also. So a little bit of data, you know, one of these snapshots is not, it's very far from knowing what happens to the Neanderthals. We are very far from that, but this is a grain of sand. So, for example, we know now that most of the sequence of El Sal that we have investigated stratigraphically, sampling the profile at centimeter intervals, regular intervals, we know that the plants that are there during the time from 60 to 40,000 years ago is not a desert, it's not a steppe, you know, it's not, Spain was arid, and that's what we knew from the lake cores and from the ocean cores. But here, it's not so dry. It's fine. There's wood, there's trees, there's all kinds of plants. And this we know from analyzing the alkanes. It's this fraction of lipids that is on the cuticular surfaces of leaves, the waxes, the leaf waxes. So we know this. And the other thing is that it's very well preserved because it's good preservation of itself. So the molecular lipid record of itself is very good, very pristine, it's very good, well preserved. So we have that. And then in the upper part of itself, we have Apache data. This slide, I'm not going to go into details. My point here is to just show you that when you want to do isotopic and climatic reconstructions based on molecular data in archaeological sites, it's difficult because sediments are open systems where there's a lot of things going on. There is, you know, you want to explore the carbon cycle and the hydrogen cycle, there's a lot of factors. There's bacterial degradation, it's very complicated. And the first factor that complicates things is the preservation. So, you know, for obtaining climatic data from lipids, you need 0.006 milligrams of sample. And sometimes we don't have that. It's not enough. That's why you just have dots. With constellations, they are loose, but not a very beautiful sequence like you may have in a lake core, for example. It's patchy. So we have to, it's difficult to interpret. So with a record like this, we have to work. It's like doing Paleolithic archaeology, right? We have very little information, so in this scale, it's the same. So the first thing we need to do is to go at what we know about the region, how does Eastern Spain, how does the climate of Eastern Spain relate to the isotopic signature of hydrogen today? There is that information, and that can narrow things down. So we know that the hydrogen signature of that you get from Eastern Spain is related to moisture and is related to the stress that plants get. We know that. So we are applying that to the past, and then we apply ratios of the leaf waxes. The leaf waxes, you can play around with the ratios between them to derive other ratios like the vapor pressure deficit and things related to moisture to get an idea of conditions of aridity. And from all that data, we do see that there's an arid trend towards the top, where we get the last Neanderthals. So it did become drier. Something happened there that got drier. And it's not a matter of a new source of sediment because the rock fell or something like that. It's a true climatic signal. And that's what we are working on right now. On the bottom layers, before 40,000 years, the life of those Neanderthals in the region, we see a lot of organics that we should imagine this as more like today's German soils, black soils, rich, full of worms, full of organics degrading and rotting from more rainfall. Eastern Spain today is very dry. It's a very high contrast seasonal Mediterranean climate. But back then, we have evidence from thin sections that tell us that it was very bioproductive. It was very wet, probably rained more months of the year. So again, it's about how much it rains rather than being cold or not. So we have several clues. We have hackberry seed coats. A hackberry tree does not tolerate too cold temperatures. It's a Mediterranean thing. So it is more about humidity, it seems, not about cold. We don't have any evidence of frost and freezing in this site. There's no frost. It looks warm and it looks moist down there. So, and it also looks very natural. It doesn't look very anthropogenic. There's no heavy trampling and compression from living there or anything like that. It looks like, a soil scientist would say, oh yeah, this is soil. Yeah, all horizon, a natural thing. And this, talking to the other specialists, ties in very well with what we think of Neanderthals being very mobile. They just didn't stay there very long. They did a fire one night and left. But we are looking at all that deposit in a flash, and it looks full of fire, so we think, wow, anthropogenic, high dense, base camp. But in reality, it may be, I don't know how many times they went there, but maybe not many times, because they are outdoors people in a very nice landscape with good weather. Why would they live there? There's not even a cave, right? This is evidence of that, in my opinion. Other little grains of sand, other little snapshots. We have a very interesting case in which the anthropology people, charcoal specialists, find a lot of pine in the fires. Charcoal, pine charcoal. But the lipid signature of those burned floors, which is the floor, this is the natural substrate, is angiosperms. There is no conifers there. So that means that they like the pine as a fuel, but the pine forest was not there. They're bringing the pines from somewhere else. So in the floors, we have hackberry and we have angiosperms, but we have no lipid indicators like terpenes or other indicators of conifers. So that's one thing that is related to behavior that could be relevant to know the Neanderthals a bit better. In fact, the Neanderthals from most of the Iberian Peninsula and southern plants, they love pine for burning. It's very expedient, it burns quickly, and it's fast, no investment. So this is a lot piece of evidence that supports that. Another study that we did is to document really, really well as we could, a case of a pit fire. It's not very common in the Neanderthal world. They just made simple barbecues, maybe also because they were in a hurry and it's easy. And there's not many cases of that. And the cases that are in the literature don't have high resolution data associated with them. So let's say for our purposes, and this ties into what I was saying before, as using our case studies as reference material. Our story behind this fire is just a big fire. It's full of ash and it was used more than one time. Okay, but for us it's important because we are documenting all the manifestation of that fire in the different domains. So we have the lipid evidence associated with all the layers of that fire that tell us that everything is gone, because it's a high combustion with very hot temperatures where nothing preserves. It's more than 400 degrees, the lipid signature is gone. You have that little square there and everything is gone. We confirm that it's wood ash, that we have ash there, that is combustion, real combustion. And then we have archaeomagnetic data to verify that the record, the archaeomagnetic record, which involves the heating and going and cooling of a ferromagnetic mineral in the soil, is very reliable. It went down really well. So it tells us that this is really in situ, and we see the high temperatures, 600, 700 degrees. So we have a high temperature feature there. So to us, this is reference data. You know, now in the literature, there's reference data that someone else can go to and compare with. That is our contribution. So where are we at? You know, is it just another piece of the puzzle? It is. It's just another piece of the puzzle. And that's why you read all these papers and they don't look interesting. It's like, what about Neanderthals, right? But there is more. I think where we are going, okay, we're not there yet, but the goal is, if you imagine that the story that you're telling is, you know, every bit of information, every paper is a page in the prehistory book, you know, it's a page of what happened. We have pages. We have, okay, in the south, layer 10A, we have this, they nabbed this flint, they did this, they did that, high resolution, isotopes, diet, climate, and we have that page. But because it's in the change, the story is in the change from one thing to the other, behavioral change, climate change, we need to know the page number. We need to know in the novel how you organize all that, because it's very subtle. We need to know what the order, the relative chronology of the data we have. That's the next challenge. So in the south, our way to approach this is with archaeomagnetism that is linked to microstratigraphy, linked to the thin sections, and linked to archaeostratigraphy. So archaeostratigraphic analysis, we get the stone tools and the bones, and then we try to isolate assemblages following the laws of stratigraphy, steno, just superimposition of material, together with the microstratigraphic data. And then thanks to archaeomagnetism, we are able to calculate time in an approximate way with models, with temporal models. And this is because archaeomagnetism, you know, that when you fire something, the ferromagnetic mineral acquires a new remnant magnetization. It's called thermal remnant magnetization. And this is the orientation of the north of the time of burning. So our simple exercise is to say, if we have fires, like in this picture, they are on the same surface. They look contemporaneous, they're on the same surface. And they have different declination and inclination. They're not contemporaneous because they have different magnetic norths. It's really it's a rule of thumb, common sense approach. So that's what we do once we find that diachrony, is to try to explain, we try to model the minimum amount of time that is necessary to explain that difference in angle. And we do that through the models of secular variation that we know that exist, model to the past, and with statistics, of course. And the statistics are related to the acrostratigraphy and microstratigraphy. That with the laws of superimposition, we know which fire was before and which one was after. So that helps us constrain the model. For El Sal, if this is correct, it's very important, because if you see the time differences between fires that were supposed to be contemporaneous, is more than one generation of people that live 50 years, right? So we are trying to look together at lithics and bones of assemblages that are almost 100 years apart or more. So this is our contribution in this case, to stop, to say stop, and maybe analyze the assemblage of this fire alone and that fire alone, and then infer from there. And Aviv del Pastor, which is the neighboring site, we have also that time period, but we have a little bit before that. You know, if we're talking about the disappearance of a population, this is a major event. It's like a biological extinction almost. So it requires probably millennia until leading up to that. And in the climatic record, we know that the millennia leading up to 40,000 was very unstable. And there's specifically one climatic event period, MIS4, or one glacial period that was very hard for Europe. It was hard, it was very cold, and it's supposed to have been the thing that just the Neanderthals couldn't deal with, hypothetically, and cause instability in the climate and the animals in the plants. In this side, we have that chronology between 60 and 70,000 years ago. So we are trying to see what happened there. Also, we have fires. So the first thing we had to do, this is another grain of sand, is prove that we have fires, because you know that right now there's a big polemic in the Neanderthal research world about fire, and do we trust the fire evidence? Because maybe it's not fire and Neanderthals didn't have fire. There's a big debate. So we have to make sure that we show that the fire is fire. We have to produce clean literature. And so we did all kinds of study with magnetism and with microstratigraphy and microspectroscopy to say that ash is ash, and charcoal and burning, and so we have that. And then we also have we're lucky that it's a very tiny site, very poor. So you have sandwiches of rocky levels with nothing, and then a ridge level with 70, 80 things that you can analyze together. You can do a lot of analysis together. So we think from our analysis that we might have very small amounts of time there, where we can really look at behavior of individual occupation events. That's what we have in Pastor. So we're trying to see what those Neanderthals were doing based on that. We don't know yet. So that was for the Neanderthals. And I'm going to now just maybe close. I don't know what time I have, but I'm going to try to wrap it up. And not without mentioning some of the other work we are doing in different archaeological contexts. So I'll give you also in this style a little bit of snapshots, not big theories. I don't have any big theories, but some snapshots of the archaeology that we have been doing in the Canary Islands, which is another very interesting experimental ground for us. Because, you know, as geoarchaeologists, again, we are experts in taphonomy, diagenesis, alteration, and the Canary Islands was first settled around the change of era, you know, or between 0 and 200 AD. So it's recent. So we can have a nice chronological control of what processes happen. So from site formation perspective is interesting, and that motivated doing work there as reference. So one of the studies that we have, and this is by a team member in our group, is about the high altitude adaptations in the Canary Islands. In the Canary Islands Aboriginal populations, it's quite high in the Canary Islands, and up in the mountains it's above the tree line. So it's likely that it was only a seasonal occupations in the summer. It was a community, and the island in those times was heavily reliant on pastoralism and not so much in agriculture. So the hypothesis about the people there is that they were shepherds that moved up and down in the island seasonally. So we found there's a rock, a volcanic tube, a lava tube that has thick deposits of Aboriginal time period that we are studying, and it has fire, of course. So we went there to see what was going on, and we sampled. And originally, we went there to study one fire that they found. So the first surprise was that it was a site that had been visited frequently. It was not just one fire. So that was the first result, is that there is recurrent occupation of that rock shelter, and all the floors had a lot of combustion residues from firing there. So that's the first thing that we had to say. And then linking that to the lipid records, we realized that the fuel that they were using was a small tree, the juniper, Mediterranean juniper, that is not present there today. It's only present at lower altitudes. And the vegetation in this time is not supposed to have changed drastically. So it's possible that they were carrying special fuel up to this site and using it for fuel rather than gathering whatever dry bushes they had there. So it's another little piece of information that we can know about these shepherds and how they procure their fuel, how they moved in the landscape and explored the resources. Finally, another case that I will mention, just to really wrap up now, is a cave that has a fumier. Fumier is a French term that refers to a deposit of shepherds, pastoralist societies, and it's the deposit that is generated after stabling sheep or goat, typically, and after abandoning the site and burning it for cleaning it from parasites and just getting it ready for the next occupation. It's something that it's a good, it has been a target of geoarchaeological study for a long time, but it's very typical of the Neolithic and the Bronze Age. It's in that time, there was a lot of pastoralism, and it's something that we find often in Europe and Eurasia. And this for us is interesting because it's more recent. So we have a tighter control on site formation, and just as reference is interesting. And it's also interesting because for now, La Palma, one of the Canary Islands, is the one that seems to have more fumiers. It's like a tradition of fumiers. We don't know if it came from North Africa as a tradition, or if it's something that you would do naturally, common sense, to get rid of fleas. There's like a hygiene, natural human behavior. But in any case, it's interesting to document it very well for later testing this. If it's a tradition or not, if it comes from somewhere or not, the Canarian Aboriginal people were Berbers from North Africa originally. Can we look at fumiers from North Africa and find something cultural in that? We will only be able to do that if we document this deposit very well at high resolutions as an artifact. So the concept of sediments as an artifact, right? To have a good documentation that can be used to test cultural hypotheses. Because here, there's just sediment. It's a cultural deposit with fire, but there's very few other records. So you have to study it from an geoarchaeological perspective. In this study, the main contribution was to estimate more or less how many burning events there were in these 600 years in which the deposit was formed. Of course, there could have been more, right? When you don't have something, it doesn't mean that there was not there. You could have it somewhere else, or it could have disappeared. But in any case, it's an estimate. It's an estimate that has to be tested with other cases to see the rate of burning in other fumiers, in the islands, in North Africa, wherever. But this estimate is based on characterizing and making sure that each layer is what it is. So this one looks like ash, but we have to certify that. We have to do the relevant analysis to say that's ash. That is the essence of geoarchaeology, of our microstratigraphic approach, is to answer the question what first. What is that, and how did it form? So that is our job. That's what we do. So we estimated more or less the amount of burning events. We certify that it's done, that it's gold or sheep, that is microscopically its characteristic done. And we also produced a lipid profile from sampling at very small intervals together with micromorphology, showing that show that the signature of the leaf waxes seems to go towards herbaceous grasses. That seems to be what the diet of those animals were. So, because goats can eat even plastic, right? So you never know what they can eat. And in that site, that's a site that is coastal, it's very variable vegetation. So it's interesting to characterize what they ate. So we have a lipid record that leans towards grasses. The lipid record was explored furthermore to try to distinguish with this approach called the fecal biomarkers. It's a whole field. Fecal biomarkers is a field. And it started with a lot of background from chemistry, from the agro industry that analyzed the pollution of waters, right? So we have a lot of agro and food industry and environmental data of when the water is polluted by what animal. We know that. And this is related to bile acid traces and lipid traces. So that's why we can do it. And this is all related to analyzing ratios and proportions between this bile acid and this other one, different lipids, and what prevails and what not. There's a whole system. This analysis led us to conclude that the producers of those lipids in that fumier are probably sheep or cow. But in La Palma Aboriginal times, there's no cows. They were introduced by the Spanish. So that's something that we can use to narrow the result down. So we now think that they were sheep. And this is very relevant because the behavior of sheep is so different from goats that stabling and moving the animals is very different. And the products that you obtain from one or the other is very different. So it's really relevant to understanding pasture-led communities in this case in La Palma and between the 9th and 15th centuries. So this is another grain of sand that we are contributing. And then our goal is to continue in this line. We are just beginning. We have a lot of protocol improvement to do related to that slide that I showed of the hydrogen isotopes with a lot of empty melts. It's complex. It's very complex, and it requires experts from the chemistry and from other fields to try to help us design protocols, reliable, robust scientific protocols to tackle sediments that are from archaeological sites. This is a similar problem that geneticists have. They still have it. Understanding how the DNA degrades and bacterial interactions in the sediment. This is the same thing. So this is where we still want to go. And then everything that I showed you today, all these case studies are not really from getting the sediment from the block or the thin section, which is what we are already doing with DNA. It's not like that. We are starting to do that. We have some pilot work that shows the potential. It's difficult because the resin we use to impregnate the blocks is polymers. So it's very difficult to tease apart the possible interactions between the polymers and the lipid compounds, which is lipid compounds are, like hydroxyls and carboxyls. So it's difficult. But in our pilot studies show that it's possible. And the principle behind it is that the resin coats the soil matrix, but does not penetrate to the core of things because of physics. It moves before it penetrates. And there's a lot of porosity, so it goes to the pores, it dries, and the center, the core of the microparticles are intact. So for now, the success has been with things that are big, a few millimeters, or with black layers that are very thick and have a lot of organics that statistically you probably get some lipid signature that is intact. But much more work is needed on this. So this is where we want to go. We also are going towards analyzing the magnetic properties of fired stuff directly from blocks and thin sections too. And there is a technology to do that. So there is instruments in the magnetic research, geomagnetism research, that have stages and that can handle thin sections of blocks. Of course, that's where we want to go. We have spectroscopy doing that. We have many techniques that are microcontextual directly from blocks and thin sections, and this is a missing gap that we want to cover. And then the other thing is that we want to spend less time describing thin sections. And AI is eating the world, and of course, this seems like an easy problem. So we are trying to push this development of machine learning to just teach neural networks to describe bones and flint and charcoal, and this is going to require collaborative work, but we all collaborate. So we're all online. So I think this is a promising field that we want to keep developing. And I think that combining, especially knowing that we are still in this stage, is really the stage in where we're developing the methods and we are contributing little pieces of the puzzle. And mostly they're out of order without page numbers. That is the first step of being aware, having awareness of how far we are from testing real behavioral hypotheses. But at the same time, if we take a microhistoric approach, theoretical approach, we are contributing behavioral and climatic and adaptational data that we should be very conscious that is directly relevant to understanding people. It's like reconstructing what you do every day. So that is, I think, how we are advancing archaeology, not just a technical field in archaeology, but archaeology really. I think I will stop there. Thank you, everybody, and thank you especially all my collaborators. I'm just a spokeswoman here. Yeah.
Thank you, Carolina, for the excellent talks. Very inspirational, like so many ideas that come out from what you just said. It makes us wonder how can we bring those things to our own context, and what can we do with our own research questions? Because you have your own, right, with Neanderthals and even the Canary Island context. There's so much to do with these techniques that will bring novel information. So, eu vou abrir agora só para... Não temos muito tempo para perguntas, mas também não vamos deixar sem a chance de quem quiser fazer uma pergunta para a Carolina, aproveitar esse momento agora. Se alguém tiver uma pergunta... Questions, doubts, comments?
Hi, Carolina. Thank you so much for your presentation. It's really inspiring and it's outstanding research. You say it's like these grains, but it actually you put together in your presentation. And for us, it's like this puzzle. Seems very intriguing, actually. I was really interested when I said that the fires are not contemporary, but there is hundreds of them. So I was like, well, maybe we are then seeing this place that like maybe have a meaning if people are coming back to it. So I know you said you are not into the hypothesis, but my mind went there. Into this. No, sorry. You said hypothesis, not like big theories, but I was like, yeah, but maybe we are seeing this space that is strategic, but it's a recurring place, and people over generations are coming back to it. And so, would you say we are talking about like these memory places, or a place, especially with people bringing firewood from elsewhere, like it's a place of ancestors to visit or something like that? Could you comment on that a little bit?
That is a very interesting, very relevant question. I didn't want to focus on that side, you know, I wanted to touch on other things, but yes, we don't know, of course, but what we know is that 40-meter wall is slightly tilted so that the first meters close to the wall, you don't get wet, and you're blown from the wind. So it's like a shelter, really. And we know from all the coprolites of all animals that not only humans like that place. It must have been a nice place. And then I didn't have time to tell you that, but there is an important river flowing by with tributaries and a waterfall. So there's a source of water. Water is underestimated. You know, people need fresh water. And there's a lot of water there. And in fact, we are starting to see, especially from raw material studies of the lithics, that maybe the territory of these Neanderthals was referenced based on the river. There's something about the river that we know now how to distinguish raw material that is taken directly from the flint outcrop, or from the secondary source in the middle of the river, or in the Mediterranean. We know that. So we can follow where in the river they moved. And we are starting to see that they didn't cross to the valley in the other side of the river. They stayed in this river, and in the other side of the river, there is also Neanderthal sites with a different kind of flint. So we are starting to think of these Neanderthals as their world was this river. And maybe this was an interesting stop because it was full of life, and there's this wall that is a good shelter. So it's a good place to live, and the evidence shows that yes, they came back very often. The only problem that we have to remember, I think, is that maybe other places in the landscape were also like that, but they're not preserved, right? So we have a good preservation there because due to the sediments that cover the entire deposit that have preserved it. But we don't have access to, so absence of evidence is not evidence of absence. So maybe the whole valley is full of fires, and if you've traveled to that time, it would be like smoke, 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 smoke everywhere. But we only have this side. These are like our only evidence. So this is a very hard question to answer, I think. But for sure, it's a nice place. They like it. Yeah, yeah.
Se alguém quiser fazer uma pergunta em português para a Carolina, a tradutora traduz para ela, tá? Se alguém ficar meio com dúvidas de perguntar em inglês, tudo bem. Segue.
Inglês ou espanhol?
Para inglês. Inglês só para
A very important part of your talk is about magnetic properties. And the most important site, this behind the wall, is open air site. So there is a lot of pathogenesis besides human activity in this place, and your field sections, I think, show it.
Yes.
Do you have really firm criteria to distinguish between pathogenic magnetic enhancement, and means mostly biogenic fine-grained magnetite, and pyrogenic signal with also fine-grained pyrogenic magnetite?
Yes, I believe that we have enough to work with, because I didn't present it here, but we did experiments before we did the archaeology. We had an experimental program where we did 24 fires, and then some of them we left for 5 years. And in those 5 years, there was worms, there was plants with roots this big, with bioturbation. We were documenting that. And then we collected micromorphology blocks, and we collected archaeomagnetism blocks. Micromorphologically, I was even thinking there's nothing there was not a ash layer, it was a gray, it looked like these cereals, the cruisely, it's like balls, gray balls on top of the black layer, but the black layer was intact. It was really in place, and in the thin sections, there was some bioturbation going through the black layers, but in the magnetic properties, this reversibility of the signal, when you measure how the natural remnant magnetization goes to the thermal one, the curves were very sharp and very good for the magnetic properties, and they really indicated synchrony, and they were reliable for our experimental context. So that's why we can translate that to an archaeological context. And if we look at the black layers alone, because the ash layers, which is the we showed, and we have seen that for magnetic properties, no, because the ash is really, really mobile. There's research by Takis Hakana showing how ash is really, really mobile. But the black layers are something different. So that's why we rely on that.
Okay, thank you. I think no one has just the last one.
First, thank you for the presentation. I'd like to ask, with your research and your results, is there a hypothesis for the disappearance of the Neanderthals that you are fond of, at least in one of those sites?
No. I'll tell you why. Because we do see climate as changing, but we see a very patchy resolution, as I said, not that the resolution to see really change that influences people. And you never know how people are going to adapt to climate change. Look at us now, right? We are very unpredictable in that. And we don't have the resolution to look at that yet. That's what we want. And actually, in our project applications, is testing the climate change hypothesis, because it's the only one that I believe we can test. The other ones about cognitive differences, and that is a game of words that is very dangerous, in my opinion, and at least I don't have the scientific mechanisms to tackle that. So I think that the climate hypothesis is the only one that maybe we can challenge, and we're trying to get there, but we are far from knowing the specific adaptations that they might have. Right now, we are looking that in that part of Spain, it doesn't seem to have changed much. It's a bit drier, but the fauna didn't change much, and the plants didn't change much. So there must be other things happening, maybe in Northern Europe, Central Europe, that changed, climate change and populations came down and put pressure on our Neanderthals. Maybe that actually seems to be happening. But again, it's a very complicated problem that I have not seen before. Okay.
Thank you. Thank you, Carolina, once again. Vamos fazer só uma pausa super breve, 5 minutos, banheiro, aguinha, e a gente já começa então com as apresentações da hoje à tarde. Eu vou pedir para o pessoal, não sei qual quem é o primeiro me apresentar agora, mas já vem, vai ficar perto. 5 minutinhos, tá bom? Pausa. Vou pegar. Você tinha interesse no que para ficar 5 minutos, 2 minutos. Você pegou da pasta que eu tinha ou você tinha outra coisa?